Welcome to this video on essential mathematical skills in chemistry. I am Arnold Villaro, and you can reach me at the email address provided on the slide. We begin with expressing numbers in standard form, also known as scientific notation. This is a special way of writing very large or very small numbers. A number in standard form is written in two parts that, when multiplied, give the original number. One part must be between 1 and 10, and the other is a power of 10. The general expression is a multiplied by 10 to the power of b, where a is any digit between 0 and 10, and b is any integer, positive or negative. For our first example, let's express the number 4,500 in standard form. The solution is 4.5 times 10 to the power of 3. In the second example, we express the number 0.00067 in standard form. The solution is 6.7 times 10 to the power of negative 3. Now, try expressing the following numbers in standard form: 0.00145, 0.335, 67,413, and 300 million. Next, let's discuss significant figures. These are the digits in a number that carry meaning and contribute to its precision. Our first guideline for significant figures is that all non-zero digits are significant. For instance, the number 6,753 has 4 significant figures. The second guideline states that zeros between non-zero digits are significant. In the number 40,072, there are 5 significant figures. Third, zeros to the left of non-zero digits are not significant. For example, 0.89 and 0.089 both have 2 significant figures. Fourth, if a number ends in zeros to the right of a decimal point, those zeros are significant. For example, the number 9.0 has 2 significant figures. Fifth, in a figure without a decimal point, the rightmost non-zero digit is the least significant figure. In 7,900, the least significant is 9. The sixth guideline addresses rounding. If the digit after the last significant figure is 4 or less, the number is rounded down. If it is 5 or more, it is rounded up. For example, 14.628 to 4 significant figures is 14.63. When expressing numerical results, the final answer from addition, subtraction, multiplication, or division must be quoted based on the number with the least number of significant figures. Consider adding 2,345, 7,800, and 934,456. The answer is 940,000, not 944,601, because 7,800 has the least number of significant figures, which is 2. For the calculation shown, the result of 424.8722222222 when rounded to 2 significant figures is 420. Accuracy is how close a measured value is to the actual value, while precision is how close the measured values are to each other. Let's consider 3 measurements: 30.01 grams, 30.02 grams, and 30.03 grams. If the actual value is 30.0 grams, all 3 measurements are accurate because they are close to the actual value. They are also precise because they are close to each other. Moving on to graphs, these are pictorial representations of data values measured in an experiment. Graphs can be presented in the form of line graphs, bar graphs, or pie charts. Line graphs use points connected by a line to display data. A line graph must include a title, axes, scale, and origin. This slide displays an example of a line graph. Bar graphs display data using bars or rectangles to show comparisons between different categories of data. Similar to the line graph, a bar graph should also include a title, scale, and axes. This slide provides an illustration of a bar graph. Lastly, pie charts display data in the form of a circle, with various sections or segments. Each segment represents a certain proportion or percentage of the total, which is 360 degrees. This slide visually demonstrates a pie chart.